Hi, I'm David Guidi. This is my Circuits 2 Final Project Submission Part 1. We'll kind of zoom in here and look at the circuit. The purpose of this circuit is to take two stereo channels, combine them into single channel, and then it also needs to have volume control. So we'll kind of just pop up right here and get right into the demonstration. So the first thing we need to do is turn on the power supply. This will provide plus minus 5 volts on the rails of the op amps. Next, we'll turn on this signal generator. The signal generator is providing 800 millivolts on both of its channels, which are simulating the two audio channels. So right now, the stage 1 is getting, on each channel, it's getting 800 millivolts DC. And we'll also turn on the oscilloscope to kind of see what's going on here. So if we look in right here, the orange is the input of one of the channels, and we can see it's about 800 millivolts. Our output is the purple. It's at about 4 volts. Now this does make sense. So if we come over to the schematic here, if we look, this first op amp is summing the two circuits into a single signal, and it's also inverting it. And so if we look, so 800 millivolts on each, we add them together, we get about 1.6 volts. And if we look, there's about a 2 gain on the op amp, So that 1.6 volts becomes about negative 3.2 volts right here on this line. It then comes up, hits the second op amp. At max volume, there's about 1 gain on this op amp. So the output of and then it inverts it also. It inverts it back to the original. So in theory, it would be positive 3.2 here. But it's not exactly a 2 gain. It's actually a little more than that. So in reality, we are getting about 4 volts. And that's about also what we get in simulation. So everything is making sense. So now if you bear with me, I'm going to put the phone down for a second. Now what I'm doing is I'm turning this potentiometer all the way down so that the resistance through it is 0 ohms. And if we just kind of pop back up to the schematic here, here's the circuit with the potentiometer turned all the way down. And then just bear with me, we're going to pop back up to the schematic here. And so when this potentiometer is turned all the way down, this now has a 5.7 over 15.7, a gain less than 1. So it's going to attenuate the signal. It's going to make the signal smaller. That's why we're able to use it for the volume control. Now, if we come over back to our Scopy, we can see that did indeed happen. The input signal is at about 800 millivolts signal, but now our combined attenuated output signal is at about 1.2 volts. So that's about the voltage at minimum volume, at least when there's 800 millivolts DC on the input rails. And that is the stage 1 completely working in this scenario. So I just want to quickly go over the circuit. So that IC down there on the breakout board is the actual op amp. There's 2 op amps in that IC. I chose it because I liked that it was on the breakout board. I liked that there was 2 op amps in it. It could do the plus minus 5 rail-to-rail voltage. And so that's why I chose that as the op amp. And that's the potentiometer for the volume control. And then just one more time back at the schematic here. They're the same op amps. And yeah, there's the potentiometer for the volume control. Just trying to make sure there's nothing I didn't miss here, but that is the stage 1 completely working. Thank you.